Hey guys, welcome back. So today we're gonna practice the method of undetermined coefficients that we saw in the previous video. So I'm gonna go with 2 or 3 examples. So let's start with this question. So as you know, your y is always equal to yc plus yp. So first let's work on finding yc. So what you have to do to find yc is you're gonna simply ignore the RHS and you're gonna write it as 0. Sorry. When you're writing in your exam, make sure you mention that you're finding the CF first. So operator form. Now replace D with M. So this is M minus 3 whole square. So your M1 is equal to M2 is equal to 3. So in this scenario, your YC is equal to C1 plus TC2 times e raised to 3t. Now when you're finding your PI, we're going to use method of undetermined coefficients, which means you're going to look at this RHS and you're going to assume your YP. So as you can see, your term is basically e raised to minus 2t. So we are going to assume our PI as a times e raised to minus 2t. Sorry, this is all x, not y. So let's find xp dash, that is minus 2a e raised to minus 2t, and xp double dash is 4 times a e raised to minus 2t. Now let's plug it into the original equation. So that's x double dash 4a e raised to minus 2t minus 6 times x dash minus 6 times minus 2a e raised to minus 2t plus 9x. So plus 9 times a e raised to minus 2t is equal to 5 e raised to minus 2t. Now let's solve this. So this is 4a e raised to minus 2t plus 12a e raised to minus 2t plus 9a e raised to minus 2t is equal to 5 e raised to minus 2t. So when you add this, you get 25 a e raised to minus 2t is equal to 5 e raised to minus 2t. So you can cancel out this. So a is equal to 5 divided by 25, which is 1 by 5. So your xp becomes 1 by 5 e raised to minus 2t. So your final solution is x is equal to xc plus xp. Our xc was this, so c1 plus tc2 times e raised to minus 2t, and your yp is 3t minus 3t plus 1 by 5 e raised to minus 2t. So this is your final answer. Now let me give you an example where the linear dependency issue comes in so that we can understand that better, because you're going to encounter a lot of problems which have that issue. So let's go with this. X double dash plus 4x is equal to 3 sine 2t. So let's find our CF first. So d square plus 4 is equal to 0. Replace d by m. M square plus 4 is equal to 0. So your m1 becomes 2i and m2 becomes minus 2i. So if you compare this with alpha plus minus I beta, your alpha is 0 and your beta is the coefficient of I, which is 2. So CF is equal to e raised to 0 C1 cos 2t plus C2 sin 2t. And as e raised to 0 is 1, your CF becomes C1 cos 2t plus C2 sin 2t. Now let's go ahead and find our PI. So our RHS is 3 sin 2t, right? So we're gonna assume our PI as A sin 2t plus B cos 2t. Now you can see that sin 2t and sin 2t are similar terms, which means if we divide these, we're gonna get a constant. This causes linear dependency. Same with B cos 2t and C1 cos 2t. These terms are exactly similar. So again, what do we do when we encounter linear dependency? We multiply the terms with t. So we're going to multiply this term as well as this term by t. So I'll just add a bracket and we can multiply both of them by t together. So now let's find xp dash and xp double dash. Remember guys, when you are going to differentiate this, use the product rule because you have t multiplied by sin 2t and cos 2t. So let's take this as the first term and this as the second term. In product rule, first you're going to ignore the first term and you're going to differentiate the second term. So differentiation of t is 1 plus you're going to ignore the second term and you're going to differentiate the first term. So a sin 2t becomes 2a cos 2t and b cos 2t becomes minus 2b sin 2t. So now you're going to find xp double dash. Differentiation of a sin 2t is 2a cos 2t and b cos 2t is minus 2b sin 2t. Here again we have to apply the product rule. So we're gonna ignore the first term and differentiate the second. 2a cos 2t becomes minus 4a sin 2t and 2b sin 2t becomes minus 4b cos 2t. Secondly, you're gonna ignore this term 2a cos 2t minus 2b sin 2t and you're gonna differentiate t, which is 1. Now let's simplify this a little bit. So 2a cos 2t plus 2a cos 2t is 4a cos 2t minus 2b sin 2t minus 2b sin 2t is minus 4b sin 2t minus 4at sin 2t minus 4bt cos 2t. This is this term. Okay, now let's plug this into our original equation, which was x double dash plus 4x is equal to 3 sin 2t. So this is our x double dash. So 4a cos 2t minus 4b sin 2t minus 4at sin 2t minus 4bt cos 2t plus 4 times x. X is a sin 2t plus b cos 2t. Times t. As you remember, we multiplied it by t to avoid linear dependency. This is equal to 3 sine 2t. Now let's simplify. 4a cos 2t minus 4b sine 2t minus 4at sine 2t minus 4bt cos 2t plus 4a sine 2t plus 4b cos 2t. As you can see, these terms will get cancelled, is equal to 3 sine 2t. So as the coefficient of cos 2t on this side is 4a and over here it's 0, so 4a is equal to 0, which means a is equal to 0. And the coefficient of sine 2t over here is minus 4b and here it is 3. So minus 4b is equal to 3. That means b is equal to minus 3 by 4. So our xp becomes 0 plus minus 3 by 4 cos 2t multiplied by t, which means xp is minus 3 by 4 t cos 2t. Now let's write the final answer. X is equal to xc plus xp. Our xc is this, c1 cos 2t plus c2 sin 2t plus xp, which is minus 3 by 4 t cos 2t. So this is your final answer, and this is how you battle linear dependency. This is very important, and you need to make sure that there are no linear dependent terms in your solution. So I'm gonna go with one last example, and this will tackle two problems for you. So the question is y double dash plus 2y dash plus y is equal to e raised to minus x plus x square. So firstly, let's find the CF. So d square plus 2d plus 1 is equal to 0. Remember, when you're finding your CF, you just write the RHS as 0. So now replace d with m. M square plus 2m plus 1 is equal to 0. So this is m plus 1 whole square. So your m1 is equal to m2 is equal to minus 1. So your CF or your YC becomes C1 e raised to minus x plus x times C2 e raised to minus x. Now let's find out our PI. So our RHS is e raised to minus x plus x square. So you're gonna have to deal with this and this, both of them. So first of all, you're gonna assume YP. So it's e raised to minus x. So you're gonna assume a times e raised to minus x. But now this is same as this term. This is linearly dependent to this term. So what you will do, you will multiply it by x. But now this entire term is linearly dependent to this term. So you will multiply it by x again. Remember this, any term should not be linearly dependent with any term at all. So we multiplied it by x to battle this term. Plus, since you have a quadratic over here as well, so you're gonna take plus bx square plus cx plus d. So this is your entire assumed yp. Now let's find yp dash. First let's write the yp again. It's a x square e raised to minus x plus bx square plus cx plus d. Now let's find yp dash. Let's just take a as common. So again, we're going to use product rule. You ignore x square and differentiate this. So this becomes minus e raised to minus x plus ignore e raised to minus x and differentiate x square, that is 2x. plus differentiation of x square is 2x, so 2bx, plus differentiation of cx is c, and differentiation of d is 0. Now let's find yp double dash. Let's keep the a outside. Again, we're going to ignore x square and differentiate this. So it becomes e raised to minus x, as minus and minus get cancelled, plus minus e raised to minus x, and differentiate x square, that is 2x. Again, plus e raised to minus x, differentiate 2x, that is 2, plus 2x, differentiate e raised to minus x, that is minus of e raised to minus x. So this is the entire first term, plus differentiation of 2bx is 2b, and differentiation of c is 0. So now you have your yp, yp dash, and yp double dash. So let's put it into the original equation, which is y double dash plus 2y dash plus y is equal to e raised to minus x plus x square. So y double dash, that's ax square e raised to minus x plus 2ax, sorry, let's just write this as minus 2ax e raised to minus x. I'm just multiplying these terms, plus 2a e raised to minus x plus 2ax e raised to minus x. Again, this is minus, plus 2b. This is your entire y double dash, plus 2 times y dash. Y dash will become ax square minus ax square e raised to minus x plus 2x e raised to minus x multiplied by a plus 2bx plus c, and plus y. Our y was ax square e raised to minus x plus bx square plus cx plus d. This entire thing is equal to e raised to minus x plus x square. Now let's simplify this. So now we have some types of terms. We have x square e raised to minus x. We have x into e raised to minus x. So let's just take them as common. So let's start with x square e raised to minus x. You get a. Then you get minus 2a. And then again plus a. The next is x times e raised to minus x. Here you get minus 2a. And again minus 2a. And plus 4a. 2 times 2 is 4. Plus 4a. The next term is e raised to minus x. You only have a 2a. And the remaining terms are plus 4bx plus 2c plus bx square plus cx plus d is equal to e raised to minus x plus x square. As you can see, this gets cancelled. This also gets cancelled. So you are left with 2a e raised to minus x plus bx square plus x 4b plus c. Sorry, we're missing one term here. Plus 2b. This one 2b. And the constants that are left are 2b plus 2c plus d. is equal to e raised to minus x plus x square. So coefficient of e raised to minus x over here and over here have to be equal. So 2a is equal to 1, which means a is equal to 1 by 2. Coefficient of of x square and here have to be equal, so b is equal to 1. The coefficient of x over here is 4b plus c and over here it is 0. So 4b plus c is equal to 0. So 4 into 1 plus c is equal to 0. That means c is minus 4. And again the constant term on the RHS is 0 and over here it is this. So 2b plus 2c plus d is equal to 0. So 2 times 1 plus 2 times minus 4 plus d is equal to 0. 2 minus 8 plus d is equal to 0. That means d is equal to 6. So your yp becomes, you're gonna plug a, b, c, d into this. So yp becomes 1 by 2 x square e raised to minus x plus x square minus 4x plus 6. So y is yc plus yp. So y becomes c1 plus xc2 e raised to minus x plus x square e raised to minus x divided by 2 plus x square minus 4x plus 6. And this is your final answer. If you guys have any doubts, leave them in the comment section. I'll be sure to answer.